Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ain Natasha binti Muhammad Zain. I'm from class CS1434A. My student ID is 2019201652.
Hello, my name is Tengku Rafika binti Engkomat Saidi from CS1434A. My student ID is 2019402648.
My name is Anish Hera binti Azmi. I'm from CS1434A. My student ID is 2019285036.
In this video, we will study about kinematics. Kinematics is the part of mechanics that describes the motion of physical objects. Kinematics deal with the mathematical description of motion of an object in terms of position, velocity, and acceleration along a straight line. The parameters that will be defined are displacement, average speed, average velocity, instantaneous velocity, average acceleration, and instantaneous acceleration. For constant acceleration, we will develop the equations that give us the velocity and position at any time. In particular, the motion under the influence of gravity close to the surface of the Earth. We say that an object moves when its position changes with time. Consider an object moving along a straight line taken to be the x-axis. The object's position at any time is described by its coordinate xt, defined with respect to the origin O. The coordinate x can be positive or negative depending whether the object is located on the positive or the negative part of the x-axis.
Now, we're gonna talk about motion along a straight line, distance and displacement. Distance and displacement are two quantities that seem to mean the same but are distinctly different with different meanings and definition. So, what is distance? Distance is the total movement of an object without any regard to directions. We can define distance as to how much ground an object has covered despite its starting or ending point. Let's understand the concept of distance with the help of the example. Imagine your friend Annie standing outside of her house. This is her original position. 100 meters away is where the convenience store located. Between Annie's house and a convenience store, there is an internet cafe. It is 50 meters away from Annie's house. Annie is having a walk going to the convenience store. She will pass across the internet cafe until she will reach the convenience store. During the process, she will cover 50 meters from her house to the internet cafe and another 50 meters until she reaches the convenience store, a total of 100 meters. When Anis finished her business in the convenience store, she decided to go home. She will pass again the internet cafe until she reached her house. The length of her journey will be 50 meters to reach the internet cafe and another 50 meters to reach her house. So if you look at the total path length from her house to the convenience store, she traveled 100 meters. Going home when she reached the internet cafe, it will be 100 meters plus 50 meters, which is equal to 150 meters. And when she is back to her house, it will be 150 meters plus 50 meters, which is equal to 200 meters. This path length is basically the length of the path, but length is also known as the distance, with the SI unit meter. Next, how is displacement defined? Displacement is defined as the change in position of an object. It is a vector quantity and has a direction and magnitude. It is represented as an arrow that points from the starting position to the final position. So let's go back to the example to make it more clear. We saw Anis travel from house to internet cafe to convenience store and going back to her house. We previously looked at the distance value, but now we will look at displacement value. As Anis went to the convenience store, the distance and displacement are the same value, but when Anis come back to her house, when she reached the internet cafe, her distance is 150 meters, but her displacement, which is defined as the shortest distance from the point of origin, her house to her final position, the internet cafe. As you can see, it's just 50 meters, but when she reached her house, which is her point of origin, the value of displacement becomes 0. Now we're going to discuss about speed and velocity. So what is speed? Speed can be defined as how fast something moves, or it can be explained more scientifically as the distance covered in a unit of time. In daily life, we use the first definition and say the faster object has higher speed. Speed is a scalar quantity which composed with magnitude and a unit. SI unit is meter per second. The formula for speed is distance traveled per time. Here's some example of speed. Speed is measured as distance moved over time. The first example is a car travels 50 kilometers in 1 hour, so its average speed is 50 kilometers per hour. We can also use this symbol, where delta means change in and s means distance while t means time. Next example, you run 360 meters in 60 seconds, so your speed is 6 meters per second. Velocity is a lot like speed, except for one important difference. It is a vector, which means has a direction attached to it. Velocity is a vector quantity which composes a magnitude, a unit, and a direction. The SI unit is meter per second, same as speed but with the directions. Now look at an example of velocity. You walk from home to the shop in 100 seconds. What is your speed and what is your velocity? Using the formula, we get speed 2.2 meter per second and the velocity is 1.3 meter per second is. Then you forgot your money, so you turn around and go back home in 120 more seconds. What is your round trip speed and velocity? The total time is 100 seconds plus 120 seconds equal to 220 seconds. So your new speed is 2.0 meter per second and your new velocity is 0 meter per second. Yes, the velocity is 0 as you ended up where you are started.
Next, I will explain about acceleration. What does acceleration mean? Compared to displacement and velocity, acceleration is like the angry, fire-breathing dragon of motion variables. It can be violent. Some people are scared of it, and if it's big, it forces you to take notice. That feeling you get when you are sitting in a plane during takeoff, or slamming on the brakes in a car, or turning a corner at a high speed in a go-kart. That's all a situation where you are accelerating. Before I go in details about acceleration, I will explain the definition of acceleration first. I found two sources of definition of acceleration. First source states that acceleration are vector quantities that have magnitude and direction, and it's defined to be the rate of change of the velocity of an object with respect to time. Second source states that acceleration is the name we give to any process where the velocity changes. Since velocity is a speed and a direction, there are only two ways for you to accelerate: either change your speed, or change your direction, or change both. Next, we will look at the diagram. In this diagram, it has three pictures. The first picture states that I'm accelerating because I'm speeding up. The second picture states that I'm accelerating because I'm slowing down. Meanwhile, the last picture states that I'm accelerating because I'm changing the direction. So, from the diagram, it can conclude that if you are not changing your speed and you are not changing your direction, then you simply cannot be accelerating no matter how fast you are going. Next, I will show the example of application in acceleration. So, let's look at the example. That is a picture of a jet. Application that's applied in this jet is when a jet moving with a constant velocity at 800 miles per hour along a straight line has zero acceleration, even though the jet is moving really fast. Why? Because the velocity is not changing. When the jet lands and quickly comes to a stop, it will have acceleration since it's slowing down. Why? Because the velocity is changing. To find the acceleration, we will use this formula. That is A equals to change of velocity over time. The SI unit for acceleration is meter per second square. Next, let's continue with graph of motion. I will only show the displacement against time graph. The first graph describes an object moving at a constant velocity. You can see that the displacement is increasing as time goes on. The slope, however, stays constant, so the velocity is constant. Here, the slope is positive, so the object is moving in direction we have defined as positive. The second graph describes an object moving at a constant acceleration. You can see that both the displacement and the velocity increase with time. The slope is increasing with time. Thus, the velocity is increasing with time and the object is accelerating. In the last graph, it has 3 points: point P, points Q, and points R. At point P, the velocity increases, and at point Q, the velocity is zero. That means an object at rest. And lastly, at point R, gradient is negative, which means the direction of velocity is changing.
Next, what is projectile motion? Projectile motion is the motion of an object thrown or projected into the air, subject to only the acceleration of gravity. The object is called a projectile and its path is called a trajectory. The trajectory is always a parabola. The motion of a projectile consists of two components, one along the horizontal axis and the other along the vertical. This choice of axis is the most sensible because acceleration due to gravity is vertical. Thus, there will be no acceleration along the horizontal axis when air resistance is negligible. As is customary, we call the horizontal axis is the x-axis and the vertical axis is the y-axis. One of the most important things illustrated by projectile motion is that vertical and horizontal motions are independent of each other. Suppose you are firing a cannon at some angle. The cannonball will follow up our bullet path during its flight before it reaches the ground. We will try to understand the movement it put a cannonball. First, it is velocity. This initial velocity can be resolved into its x direction and y direction. This means that the cannonball is moving upward while moving to the right. When the cannonball moves upward, the velocity in x direction is constant or the same as the value of, while the velocity at or along y direction is approaching to zero. When the velocity along y direction is equal to zero, the cannonball is in its maximum height from the ground. The cannonball continues its parabolic path during its flight. The cannonball experiences a motion going downward while going to the right. This time the velocity along x direction is still constant, but the velocity along y direction is approaching to the value same as the initial velocity along y direction but in negative value, to indicate that it is going downward until the ball reaches the ground and the velocity is zero. To sum up everything, the velocity along x direction is constant and the velocity along y direction is changing with respect to its position. Initially, the velocity along y direction is when the cannonball reaches the maximum height, the velocity along y direction becomes zero and the velocity of a cannonball before it reaches the ground is equal to the initial velocity along y direction but in negative value. This time, let us look at the acceleration. There is no other acceleration governing to this kind of motion, but only the acceleration due to gravity, which is equal to 9.8 meters per second squared. This acceleration is pointing downward and is constant during the cannonball's flight. Lastly, for distances, there are only two distances which we should give attention. These are the maximum height when the cannonball's velocity along y direction is zero and the distance traveled of the cannonball during its flight. Before we end, let me leave you with this trivia. Did you know that in projectile motion, to have a maximum distance travel of an object, it should be fired at 45-degree angle? That is all for now. Thank you.